This lesson is for Advanced Algebra 2-7 on fitting a model to data, day 1. This is half of a lesson that we're going to do and continue when we get to lesson 2-8. There are what I discovered to be about 3 different steps to the procedure that we're going to look at today for fitting a model to data. The first thing students want to do is look at the table or the data that's given. If it's in graphical form, it might be easier to look at the graph, but if you're only given a table, try to decide as you look at the variables if the relationship is inverse or direct. Then, once that decision's been made, you can solve for k. If the first coordinate is given, then that will be your value of k. If it's not, you'll have to plug in the next coordinate and solve. Then you'll check your results with a potentially second or third coordinate and see which of the choices makes the most sense. So first of all, let's just review all the different models that we have available to choose from. There's the direct ones, which look like that or that, and then there's the 2 inverse ones that we've learned, k over x or k over x squared. So a reminder that these are the direct ones and these are the inverse ones. So remember that for direct situations, as one variable increases, so does the other. And for inverse, as one increases, the other will decrease. So we can ask that question if we're looking at the table. As the time the independent variable increases from 1 to 3, does the distance increase or decrease? So as we're moving from left to right, it's very clear that both variables are increasing. So we're going to be working with a direct situation. So let's just quickly jot that down, that we know it's direct, so our options are either y equals kx or y equals kx squared. Now we're not quite sure which one it is yet, so we're going to continue on with our list. The next thing we need to do is find a k value. Since the first coordinate is given, if you plug in 1 for x and 4.9 for y, 1 times k is simply going to be k, so the k value ends up being that very first coordinate. So we're just going to go ahead and fill that in, 4.9 for k. And that's going to be true for both equations, because 1 squared is still 1. So now that we have our k value filled in, now we're going to pick another coordinate and plug that in and see which one makes the most sense, which model makes the most sense. So I'm going to take my next coordinate of 1.5, and I'm going to fill that in for x, and then I'm going to fill in 11 for y. I'm going to do that for both equations, and then I'm simply going to calculate and see which one makes more sense, which one is the most logical conclusion. When you multiply 4.9 times 1.5, I think you get about 7.3, which is clearly not equal to 11. So it's probably not this one. This model is probably not it. Let's take a look at the other one. So when you multiply on this one, 1.5 squared first, and then times 4.9, you get 11.025, which is definitely closer to the 11 mark. Keep in mind that the k value might not be perfectly what it's supposed to be. It might be 4.92 or 4.9 something else, which would affect why these aren't exactly the same. But definitely between the two, the one that we would pick as our model is this one. So which model would be a good fit for this data? Probably y equals kx squared. So we could go back to just leaving that number as a k. So that's the process students are going to go through in this lesson, is figuring out which type it is first, solving for k, and then do a little guess and check to figure out which one is correct from there. So the next thing we're going to do is just look at number 11 in the homework and answer that question kind of together here on the video. So let's just read through the question. Refer to the table below and the graph at the right, which show the intensity of the sound, measured by decibels, emitted from a 150 watt speaker at a distance d meters from the speaker. So the d values here, those are our independent variable, or the x, and the I, or the intensity, is the dependent, or the y variable. So we've got our 4 choices already laid out here. Which of the following would probably be a good model for the data? This time we could look at the table like we did before. As one is increasing, what is the other one doing? We could also clearly see from the graph, since they've provided us with that this is not forming a straight line, so it's not linear. clearly not forming a parabola, so it's not direct in any way. It's definitely an inverse situation. But we don't have the other branch to help us, so we're not quite sure right now if it's the inverse graph or inverse equation or the inverse square equation. So which would be a good model right now? We think it's either 3 or 4. We're not quite sure yet. So now let's go ahead and find the k for the model. Since the first coordinate is given, we're just simply going to plug that in. If that value were omitted in the table, then we would plug in 2 and 3 and we would calculate, and we'd get our k value that way. But since they provided it, we're just going to go for it. Next it says, Alex looked at the graph and predicted that when d was 8, I would be 0.62. Do you agree? Why or why not? So let's go ahead now and plug in numbers to come up with our actual model and see which model makes more sense. So let's take the first model of I equals k over d, and let's use the 11.9 for k. The d, he says, was 8, and the I, they say, is 0.62. So now I'm going to calculate on this side and see if I get the same answer. And when I do 11.9 divided by 8, I get about 1.4, which is nowhere near 0.62. So I'm guessing it's not that one. And then let's do the other equation. I equals, or excuse me, in this case, 0.62 equals 11.9 over 8 squared. So let's see if that one makes sense. And when I calculated for this one, on the right-hand side I got 0.18. So that one's not really turning out to be 0.62 either. So do I agree that his prediction was good? No, because it didn't work in either of the two equations that I know it has to be. So now use your model to predict the value of I when d is 10. So now we need to go ahead and make sure we know which is which here. So I'm going to go ahead and rewrite each equation with the 11.9 in there. And I'm going to try to figure out which one is the right one to use. Do I want d or do I want d squared on the bottom? So to verify that, I'm going to use the next coordinate, the 2 and the 3. 2 for d, 3 for I. I'm going to plug that in. So 2 for d and 3 for I. 2 for d. And same thing over here, 2 for d, so that's 2 squared, and then I was 3. So I want to see which equation is the better one. Well, if you look at this one, 11.9 is almost 12 if you round it up. 12 divided by 2 is not 3, so it's not that one. What about over here? 11.9 is about 12. 12 divided by 2 squared, which would be 4, would be 3. So that means that's the one I want to use. So I know it's 11.9 over d squared. They're giving us a d of 10, so I'm actually going to fill that in. 10 squared is 100, and then I'll leave students to go ahead and actually calculate that out for themselves. And so that's it for this lesson. Don't forget, for fitting a model to data, this was day 1. We will be continuing with 2.8 as we do more with fitting a model to data.